This video tutorial shows you how you can find a suitable gearhead based on the speed and torque requirements of your application. Starting point for gearhead selection is the application, more precisely the motion of the load. The necessary operation cycles, speed profiles and friction result in speed and torque requirements the drive has to fulfill. In our standard diagram with motor speed as a function of torque, this can be represented as points of operation. For example, a constant operation at a given torque and speed, or maintaining a position against some external force at zero speed, or speeding up a mass inertia. Usually, that's where the highest torque occurs. The use of a gearhead is advisable if the speed is low, typically well below 1000 RPM, and the torque is relatively high. Regarding torque, we condense all the operation points into a few key values: the average, RMS load torque, and the extreme operation point, usually at the end of the acceleration where the maximum load speed and the maximum load torque occur. Let's take specific values as an example. We assume that we need 2 Nm continuous torque and 4.7 Nm maximum torque for a quick acceleration to 67 RPM. A good overview of the rated torque of maxon gearheads offers the selection guide in the catalog, the red bars indicating the torque capabilities with respect to the scale at the bottom. The smaller gearheads at the top of the list are too weak. The continuous torque rating is too small. In the lower part, one finds the larger and stronger gears with sufficient continuous torque. The maximum intermittent torque of the gearhead are about 50% higher than the continuous ones. The required peak torque is relatively large here. However, the GP26A, for instance, is one of the gearhead types matching also these requirements. Let's investigate this GP26A in more detail. First thing to note is that for this gearhead there are different reduction ratios possible. Each has a different order number. The lowest reductions based on one gearhead stage can be found on the left. The highest reduction, here with 3 stages, are on the rightmost columns. We observe that the torque capabilities increase with increasing number of stages. Our application requires 2 Nm continuous, that could be covered by 2 stages or more. However, the short-term peak load can only be covered by a gearhead with at least 3 stages. They have efficiencies of 70%. Essentially, we selected the gearhead type and number of stages according to the torque requirements of our application. But now, which is the best reduction ratio to choose? As a general rule, one can state that the highest possible reduction gives the lowest motor torque. The lower the motor torque, the more chances we have to find a suitable motor later on. The highest possible reduction is limited by the input speed of the gearhead. You can find this value in the upper right corner. For our gearhead, it is 8000 RPM. It means that the motor speed should not exceed 8000 RPM for this gearhead. In order to obtain a load speed of 67 RPM, the reduction ratio of the gearhead should not exceed 8000 divided by 67. It is 120:1. The next smaller gearhead reduction available is 100:1, and that's the gearhead we're looking for. Up to this point, we have considered the speed and torque limitation of gearheads. However, it's the combined effect of speed and torque, the transmitted power, that is related to service life. The higher the transmitted power, the lower the life expectancy. Therefore, it's reasonable to limit the transmitted power as well. The corresponding values are given for the newer maxon gearheads. Putting all this together, we can draw an operating range diagram for a gearhead. It looks similar to the one shown here. If all the reduction values of a gearhead type are to be represented, a diagram with logarithmic scales is more appropriate. That's what you find on the Maxon GPX series. In addition to these considerations about torque and speed, there are other criteria for the selection of gearheads. The first one being the mechanical interface. How is the gearhead going to be fixed? And how about the shaft diameter and length? Is there flat or even a keyway needed for connecting the load? How large are radial and axial load on the shaft? Check the maxon modular system for suitable motor types in combination with this particular gearhead. Is it possible to find matching motors with sufficiently high torque? In our case, the RMS motor torque amounts to about 28 millinewton-meters. Particular conditions require special gearhead types, sterilizable versions, gears with specially high torque or high input speed, heavy-duty versions for high pressure, vibration and temperature, and other special gearheads. That's it. A short introduction to gearhead selection. In summary, first select the gearhead size and type according to the torque requirements of your application. The matching reduction ratio is found by looking at the load speed and maximum gearhead input speed. Good luck!